Sí. Good afternoon, everyone. How are we doing today? Well, I'm doing just fine. Chilling, relaxing, shooting some b-ball after school. No, no. A couple of guys up not good. No, maybe. All right, guys. Please turn on your cameras when you get ready. We got about 3 minutes to launch time. While I am waiting, any questions? All right. Good afternoon, everyone. Okay, while I'm letting everyone in,
What?
do we have many questions?
Hang on. Just click. Hang on. Just put your,
Oh, wait a minute. My volume is working. Do we have any questions? Everyone, please turn on your cameras so I can see you. Remember, I'm not just simply asking you to turn on your camera so that you know that you're there. It is actually part of the learning process. Online classes in particular, it is difficult to focus because the computer itself is a distraction. And so you turning that computer on kind of helps that process of you focusing. All right, I have one quick announcement before we get started. The video meetings, previously they had a password on them. So I didn't realize that the default was that the password was put on. But everyone should be able to access all of the previous meetings. This one's recording. Yeah, yeah. I set it so it'll automatically record. I won't forget. So in case you may, it says 0 people had watched them, so I was wondering why. And so I double checked. All right. With that, we can continue from where we were last time. All right. So how are we doing today? Anyone wants to say hello this afternoon?
Hey.
Nice to meet you. All right. Now, where am I? Where am I? Oh, I need to share my screen. Let me change these settings. Okay. All right, guys, can you see my screen? All right, so last time we were looking at lines, we are looking at plotting lines, and we were looking at solutions to equations. So we are going to actually start right there. So solutions to equations. So let's say I have, for example, I have the line y is equals to 5x plus 2 right here, and I want to find a solution to the graph. Well, it turns out that finding a solution to the graph is simply me asking you to create a table of values. And so you have your table of values, you have your x comma y. And if you remember, your x values are your dependent variables. Oh, you can go ahead. You can go ahead. Oh, learning comments, Mr. Matthew. You can go ahead first.
I'm so sorry to interrupt. Very quickly, I'm just gonna briefly just talk about some of the things that Learning Commons can offer y'all. This is a Mac 1105 class, right?
Give me 1 second. Everyone, we invited someone from the Learning Commons to come over and kind of give you guys the some information on the resource. It is a very powerful resource, and it is one that you should all take advantage of. Mr. Matthew, go ahead.
Okay. Like I said, I'm so sorry to interrupt, but I'm Matthew Daniff. I'm from the Learning Commons. I have been a tutor here for 3 years. This is my first semester as a full-time mathematics specialist after I graduated with my degree in statistics from FSU. So I cover all the classes from GED to college algebra, as well as the statistics classes and the liberal arts classes. So whatever class you take after college algebra, I will be available to tutor it for you. And we have a very strong team of tutors around me. We have 3 other full-time math specialists and a team of about 9 more part-time math tutors, and all of them tutor Mac 1105. We don't hire anybody anymore that cannot tutor Mac 1105. So we try to provide as much coverage as we possibly can for your course. If you were to visit the Learning Commons in person, which you're more than welcome to do, we have a special designated area that's actually right outside my office just for y'all. It is called the Algebra Corner, and it is a space where you can come in between the hours of 10 to 3 and just kind of sign in and work on your homework and not necessarily have a tutor over your shoulder every second. They can kind of check on you in more like a restaurant style, make sure your cup is still full, make sure you understand what's going on and that you don't have any questions. It's a great space with a lot of resources, and we encourage, especially for our online students, as it's a great way to meet some other people that are taking college algebra. And I'm also going to show you very briefly our website, which you should be able to see now. This is how you navigate from the TSC homepage to the Learning Commons. You simply go Academics, then Learning Commons, scroll down. If you wish to go ahead and log in for a tutoring session, you could do so right here with this button. If you want to just view the resources that we have, you just click Mathematics and scroll down to Mac 1105, and here is all of the um, different resources that we have for our students. This formula bookmark is our most popular, and I will be putting this in the chat. I personally am working on updating it. I know the formatting looks really bad right now. Um, but I am personally in charge of over the next week updating all of our resources with the rebrand. We had to put new logos on everything and it kind of got messed up in the process, but I am fixing it as we speak. But what is still working is our content videos. So this is the Mac 1105 class. So you'd go to the Mac 1105 Unit 1 test review if you wanted to go ahead and start studying for your first exam, which I wouldn't recommend just yet. Let Dr. Maurice teach a little bit more before you start studying for that first exam. But when you are ready, you can go ahead and click on the test review video. It's done in the Learning Commons based off the test review in your Canvas shell. So we try to make it as specific for your class as we possibly can. And if you don't necessarily want to watch a video and you are close to campus, you will be getting a text soon, um, reaching out and recommending that you come in for our live test review. It is the same as the video, except for it's done live. We do it here in person in the Learning Commons. And again, it's a great way to kind of come in, get to talk to somebody, get to be kind of, in a class type setting, working with somebody on studying for that first test. For your other classes, as you can see, we do have, as you progress past college algebra, we do have other class resources. And even if you are not looking to study math, we do also have our accounting and economics resources, our computer science and tech resources. Our science resources are amazing. So I fully recommend that you go ahead and check out our website and see all the things that we can offer you. And I will put the link to the website in the chat. But now you all know how to navigate, and I am left to ask if anybody has any questions. Okay, so I will go ahead and go on mute. I will throw my email into the chat. If anybody has any questions, feel free to reach out or go ahead and just give the Learning Commons a call as a whole. We are open 7:30 to 7:30, Monday through Thursday, 7:30 to 5 on Fridays. And let us know if there's anything we can do for you. Otherwise, have a great day.
Thank you.
And thank you, Dr. Maurice.
All right, no problem. Yeah, you guys should definitely check it out. It's one of those good habits to have is when you have a resource like that, is to just go there and visit the place. That makes it a little bit easier for you to when you have actual questions to go because you know where you're going, you know who you're going to see, you know what the process is going to be like. And so even though you don't have a question today or you don't have a question right now, it's just a good idea. It's a good habit to just go by and check the place out and see what's going on. All right. Yeah, and of course, it's math. If you need help, shouldn't, friends don't let friends do math alone, right? Right. Maybe. All right, so back to where we're going. So we finished off last time looking at the solutions of the equation. And I was trying to point out right here that if I ask you to find a solution to the equation, it is very simple. All this means asking you to just make a table of values. So remember, x is your independent variable, so you can choose any value that you want for x. Oh, I need to share my screen. How do you share your screen again? Oh, you press the fancy, fancy button. 3, 2, 1. Right, and so right now, so you just remember x is your independent variable, and so you choose any number you want for x. So let's say we choose x is equal to 2, and then all we have to do is calculate the value of y. So y is going to be 5 times 2 plus 2. So y is going to be 10 plus 2, so y is going to be 12. And so your ordered pair is going to be 2, 12. Similarly, but yet slightly different, I could ask the question in reverse. I can say, is the point, and I'll give you, say, for example, 5, 34, a solution to y equals 5x plus 2. And quite simply, what it's saying is, hey, I did some math. I plugged in x equals 5, and I got 34. Did I do it correctly? That's really what they're asking. And so you just have to go back and you have to try for yourself. So you plug in 5, and so y is going to be equals to 5 multiplied by 5 plus 2. That's 25 plus 2. That's 27. So it's 5, 27. Therefore, this point right here is not a solution. Questions there? And that's kind of where we ended. Questions there? All right. So now that I've completed a little bit of a review, so what's going to be happening? So we are week 2 right here. We're working through module 2. I'm graphing distance, midpoints, and circles. We're just about done with graphing. And then once you get done with that, we're going to move into the distance formula, the midpoint formula, and then the circle formula. All right, so with that, let's go ahead and get started on what we have to do today. Just make sure. All right, so today we're going to start with intercepts. Finding the intercepts of a graph. If I have some axes, one going this way and one going this way, and I draw a graph, this graph in my case right here is linear. It doesn't have to be, but in this case right here, mine is going to be a linear. This right here might be a graph right here. The place where the graph intersects or meets the y-axis right here, this is called the y-intercept. And the place where the graph meets the x-axis, this point right here is called the x-intercept. As you can see, mathematicians are very good at naming stuff, right? We just have come with these powerful, unique names, right? Yeah. Well, the nice thing is that whenever you are at an intercept, you get some information for free. If you consider the point, this point right here, this intercept right here, if you consider this intercept right here, you should note that immediately the value of y must be 0. This right here is y equals 1, y equals 2. This down here is y equals -1. Since I am on the x-axis itself, my y value must be 0. Okay? Questions there? That also means that I can kind of give the coordinates of the point. I don't know what the x-coordinate is, but I know what the y-coordinate is. Turns out the same thing is true in reverse for your x-intercept, for your y-intercept. If I am at the y-intercept, I get a point for free. I automatically know that x is equal to 0 if I am at the y-intercept. And therefore, the coordinates for the point will be x is 0, and the y value we would have to calculate, we'll have to find out. In the example I have drawn here, you can see that at least the y value is negative, right? But I know for sure that x is 0. I always tell my students right here, there's a nice simple way to remember this right here. It is the other letter will be 0. So if I'm saying find the x-intercept, y is the other value, y is 0. If I'm trying to find the y-intercept, then x is going to be 0. So if you just kind of lock that in right here, oh, I'm making the other value 0, that makes our lives easy. Questions there? All right, cool. So, for example, find the intercepts of 3x minus 4y equals 24. I am trying to find the intercepts for this graph right here. And quite simply, I have to do two things. I have to find the x-intercepts, and then I have to find the y-intercepts. Let's find the x-intercepts first. So to find the x-intercepts, again, I'll remind myself y equals 0. And again, part of the reason why we like finding intercepts, 0 is a very unique number to work with, right? If you multiply by 0, the answer is going to be 0. If I add or subtract 0, nothing changes, right? And so 0 right here is very efficient when it comes to mathematical calculations. So 3x minus 4, plug in 0 for y equals 24. 3x minus 0, because 4 multiplied by 0 is going to be 0. And of course, it simplifies again to just 3x equals 24. And of course, the last step, to divide by 3. And so x equals 8. And so therefore, my x-intercept is going to be at 8, 0. Questions there? The y-intercept, again, the other letter, i.e. x, must be 0. And so that will be 3 multiplied by 0 minus 4y equals 24. Again, the 0 just vanishes. And so I could have actually just skipped to this step. 4y equals 24. And then I have to divide by -4. And so y equals -6. 6 was 24. Positive divided by a negative is a negative. Right? Remember, once you have one negative, the whole thing is negative. But if you have two negatives, then that's positive. Right? And so my coordinates right here is going to be 0, -6. Questions there? Now that I have this right here, it becomes not that hard to graph the function. Plot your axes. You have your y-axis. You have your x-axis. X equals 8. So this point right here is going to be 8 comma 0, y equals -6. You have this point right here that's going to be negative 0 comma -6. And then you just draw your line that goes through those 2 points. And there you have it. You have the graph of the function. So this right here is 3x minus 4y equals 24. Questions there? All right, go ahead. Our first discussion for today. I want you to find the intercepts. Number one, 5x minus 4y equals 28. And number two, y equals x squared minus 16. Let's try those two. I'll give you about 2.5 minutes. Please let me know if you have a question. I will answer. Again, remember, you do need to submit something. This is how we take attendance, by participating. Williams, Nikita, and Francesca, please make sure you post the answers onto Canvas. Okay, that's where I'll be able to see and take attendance. Look for the discussion named August 29. It is in let me show you. If you go into modules, and then you go to this week's module, module number 2, see right here, August 29. Come here, and then go ahead and reply and post your answers there. Okay.
Can you scroll down? I think you're on mute too.
Okay, I'll give you about 1 more minute. Uh-oh, there we go. All right, who wants to help me with the first question?
So for the first one, you want to set the, you want to make, you want
Go
to
ahead.
make,
Go ahead. No, what happened? What happened? All right, anybody else want to help though? I don't know if internet went out.
I'm so sorry. You want to set the X to a 0.
So
And
if we find the y-intercept, okay, so x is 0.
you get -4y equals 28. And then you want to divide the 4 out, and then you get y equals -7.
So you get y equals -7.
And then you want to do the same thing for the x-intercept. So you just set the 4y to a 0, and then you get 5x equals um 28.
Hold on, it's coming back. It's coming. And so you get 5x minus 4 times 0 equals 28. So 5x equals 28.
You divide that and you get 5.6.
All right, so you get 28 over 5, or if you're using a calculator, 5.6. If you want to write them as ordered pairs, it will be 0, -7 and 5.6, 0. Questions there? Anybody wants to help me with question number 2? All right. The y-intercept, again, you're making x equals 0. And so that's going to be y equals 0 squared minus 16. Well, 0 squared is just as good old friend 0. And so then y equals negative 16, and that's that. That's 0, comma, negative 16. Now, the x-intercept is a much more interesting story. So to find the x-intercept, starts out just like we did before. You make y 0. And so you get that 0 is equals to x squared minus 16. The thing is, at this point, you have two options on how to proceed to get to the answer. What should tip you off right here is that because you're seeing x squared, that means at most you can have two answers. And so that tells you you may have to do a little bit of thinking to get to your answer. The question is a little bit different. The first way is you can solve for x directly. So you add 16 to both sides. And so then you get that 16 is equals to x squared. And you take the square root. But you have to be mindful when you're solving an equation, you want to go ahead and you want to give all possible answers. And so the square root of 16, you have to remember that there are two answers. Square root of 16 is plus and minus 4. This graph actually has two x-intercepts. And I was going through, I saw a lot of people just had 4 only. You have to be careful. That's by the reason why the other way, I think, to solve this same problem might be helpful. And so if you have 0 is equals to x squared minus 16, what you need to note or remember is that this is a difference of squares. And a difference of squares, like we did last week, factors. It's going to be x plus 4, and it's going to be x minus 4. All right, and then remember, you use the ZPP, the zero product property, and you will set each one equal to 0. And so you get then that x equals negative 4, and you get x equals positive 4. After you set each one equal to 0, you get x equals negative 4 and x equals positive. Again, the same two answers. But because you factor and split it into its two pieces, you can see that there are two zeros. Questions there? Let me kind of emphasize this one last time. The line y equals x squared minus 16. This is a parabola. And so if I was to attempt to graph it, I remember that it'll have that U shape, the upside down umbrella shape. Well, if it has that upside down umbrella shape and it starts down here at negative 16, the graph will grow. And because the graph will grow, it will have two intercepts. One right here at 4, 0, and one on the other side at negative 4, 0. One 4, 0 on the right side, and then negative 4, 0 on the left. Questions there? So we got to be a little bit careful when it comes to these things. All right, moving to our next section, the midpoint of a line segment. If I have two numbers, if I have, say, for example, two numbers, if I have two numbers, say 10 and 20, and I want to find halfway or the midpoint or what's in the middle of these two values, all I have to do is to simply take the average. So to find the midpoint of those two numbers, I just need to take the average. Well, the average is going to be 10 plus 20. You add the numbers up and you divide by the number of numbers. That's going to be 15, right? And that kind of makes sense. Halfway between 10 and 20 is 15. Yes? Well, it turns out that if I have a line segment, so let me draw axes, X and Y axes, X and Y. If I have a line segment, i.e., not a line that goes on forever, one that has a starting point and an ending point. If I have a line segment, to find the midpoint of that line segment, to find the midpoint of that line segment right here, what I'm really doing is simply finding the middle of the x's, and I'm just finding the middle of the y's. So mid of the y values and the mid of the x's. And so if I have a point A, which is x1, comma y1, and B, x2, comma y2, and I want to find the midpoint of the line AB, if I want to find the midpoint, I simply find the average of the x values, comma, and then I find the average of the y value. If you think of it in those terms, find the average of the x values, add them up and divide by 2. Find the average of the y values, add them up and divide by 2. If you think of it in those terms right here, you realize that there's not really a formula. It is just them finding average. The nice thing about the midpoint is that the two line segments will always have the same length, right? If I'm at the middle, by cutting in half, exactly, the two lengths would be the same. Questions there? The distance of a line segment the distance of a line segment comes from Pythagoras' theorem. You guys remember Pythagoras' theorem? The Pythagorean theorem? That c squared is equals to a squared plus b squared. You remember this fancy theorem? Again, this is kind of why it kind of happened all the time on our favorite exam in the whole wide world, the SAT. Kind of why they kept asking you about it. Is because they knew it was going to come up again later in life, you know. So if I have the same line segment, dot here, dot here, and I want to find how long this line segment is, I want to find out how long this line segment is, the length, what I need to do is I need to change this line segment into a right triangle. And so I need to add in a vertical component, and I need to add in a horizontal component. This vertical component we will call A, and then this horizontal component we will call B. Therefore, the long side will be C. Again, guys, remember this kind of Pythagorean theorem? A squared plus B squared equals C squared? All right. Well, it turns out that if this point is called A and this point is called B, just like I have higher up, and this is called x1, y1, and then this is called x2, y2, like so, I can find the length of the line C in terms of x and y. The length B will be y2 minus y1. Does that make sense to you? The length of B would be y2 minus y1. If I tell you something starts at the point 2 and ends at the point 8, and I want to tell you how far have I traveled, I have to subtract the two distances, the 2 points, right? 8 minus 2 is 6. That's how long this line is going to be, right? Subtraction gives us the distance traveled. If I start at 2 and I travel, oh, I have the wrong letters, don't I? There should be x2 and x minus x1, sorry. But that's neither here nor there. If I have a starting value, I'm starting at distance 2, and I keep walking until I get to 8. Now, mile marker 2, and I keep walking, I get to mile marker 8, and I want to know how far I have walked, right? I don't walk 8 kilometers because I started at 2. Well, 8 miles because I started at 2. So I have to subtract them. And similarly, A is going to be equal to y2 minus y1. With these two little changes in mind, I can do this. I can say that c squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Let me move that out the way. Move this out the way. Put it right here. There you go. Right? I've just put in the formula for A, and I have just put in the formula for B. Questions there? Now, I am looking for the length C, not C squared. And so what I'm going to do is I'm simply going to take the square root on both sides. And so therefore, C is going to be the square root of the difference in the x values plus the difference in the y values. And simply what they did was, because it's the distance formula, they simply changed the C into a D. X2 minus x1 squared plus y2 minus y1 squared. And that's all there is. That's your distance formula. Questions there? Let's take our new formulas for a spin. So example, given line segment AB with A being the point 1, 5 and B being the point uh-oh. Hold on, they just kicked me out. Said that there was some kind of issue. Let me try and they just kicked me out. Is the meeting still being recorded? Oh yes, it's still being recorded. Okay. I know they've been having some issues. I've been getting emails about them having I know they've had several issues with technical issues. Apparently, we're getting those technical gremlins ourselves. Share screen, share screen. Did anybody else get kicked out of the meeting? I guess you won't be here to tell me, huh? Okay. All right. And line segment B was going to be at -2 comma 1/4. And what I want to do is I want to find the midpoint of the line segment, and I want to find the distance of the line segment. So find the midpoint and distance of AB. All right, so let's go ahead and find the midpoint. So I like to label everything so it makes my life a little bit easier in the long run. So the first point, let's switch to blue. The first point, I will call that x1. Second point, I will call that y1. The next point, I'll call it x2. And last point, I will call it y2. And so to find the midpoint, the midpoint of line segment AB, that's going to be 1 plus -2 divided by 2, comma, 5 plus 1/4 divided by 2. You with me so far? Okay. So that's going to be, well, what's 1 plus -2? That's 1 minus 2. So that's going to be -1/2. And then on the other one, we have to do a little bit of work. And so I have to first add 5 and 1/4 together. Whenever we are adding fractions, we need to have a common denominator. So I'm going to write 5 as 5/1. Are the denominators the same? No, they're not. And so I'm going to multiply this by 4/4. That'll give me 20/4 plus 1/4. You should always pause and double check. Is 20/4 the same thing as 5? Yes, it is. So my conversion is correct. But now the denominators are the same. So I just need to keep the denominator and then add the numerators. 20 plus 1 is 21. And so this is going to be 21/4 divided by 2. And again, I have to work that out. 21/4 divided by 2 is 21/4 divided by 2. Keep, change, flip. So you keep the original, the first term. You change the sign to multiplication. And then you flip the second term. So instead of 2, I write as 1/2, right? Keep, change, flip. And then you multiply across. So that's 21/8. Of course, that's not that bad on a calculator. Questions there? All right. That's our midpoint. We need to find the distance of line segment AB. This is a little bit more fun. This is going to be the square root of x2 minus x1. That's -2 minus 1 squared. Notice that when we switch over to the distance formula, we're subtracting, but that's on the inside of the parentheses. It's still a plus sign on the outside. And that's going to be y2 1/4 minus y1 minus 5. And then that's going to be squared. -2 minus 1 is not that bad. That's going to be -3 squared. 1/4 minus 5. We kind of did this a second ago. This time we're subtracting. So instead of writing it as 5, you write it as 5 over 1. And again, you look at the denominators and you find the lowest common denominator. In this case, that's going to be 4. So I multiply this by 4 over 4 to make the denominators the same. 1 over 4 minus 20 over 4. And that's going to be negative 19 over 4. So that's going to be negative 19 over 4 squared. That's going to be the square root of 9 plus negative 19 over 4 squared simply means negative 19 over 4 multiplied by negative 19 over 4. And that's going to be 361 over 4. Sheesh. 361 over 4. And now I just need to add those two fractions together, but I'm going to pause right here. Any questions?
No.
All right, so basically one step is left. I need to add those two together. I need to add the 9 and the 36 over 4. That's our third time of asking for the fractions. So that's 9 plus 361 over 4. And I write this as 9 over 4. Again, the decimals might be a little bit easier to work with. But the reason why I'm doing this is that on some of the questions, they will ask for the exact answer, and then they'll ask for the approximated answer. And you need to be able to do both. So you do need to be able to do it without the calculator. All right. Oh, my bad. This should be 9 over 1. And now to get the denominators the same, I multiply by 4 over 4. So that's going to be 36 over 4 plus 361 over 4. And so that's going to be 397 over 4. Square root of 397 over 4. That's the exact answer. You type that into your calculator. 397 divided by 4. I'm going to round to 2 decimal places. And that's going to be 9.962. Questions there? All right, I'll leave this up and I'll let you try again. A is the 0.2, and B is the point -3, -4. And I want you to find the midpoint and the distance. For line segment AB. So take a minute to go back over the formulas and the examples. If you have a question about either one, let me know. And then go ahead and get to it. I'll give you about 5 minutes. Again, please post something. It doesn't have to be perfect, but it has to be your best effort. All right, has everyone had a chance to post? All right, so let's roll. So for the first one, the midpoint is going to be 2 plus -3 over 2, comma 5 plus -4 over 2. 2 plus -3 is -1. And 5 minus 4 is just 1. And so the midpoint is -1/2, comma 1/2. Questions there? Now for the distance, it is going to be the square root of x2, that's -3 minus x1, which is 2, squared, plus y2, -4 minus y1 squared. Look at what I have, double check with what you have, and make sure we are in agreement. X2 must come first, followed by x1. All right? Questions there? And so that's going to be the square root of -5 squared plus -9 squared. So that's going to be the square root of 25 plus 81. And so that's going to be the square root of 106. Questions there? Yeah, there are a lot of small sign errors that you can make in this kind of question. So you have to be specific and you have to practice to make sure that you're not misusing the equation. Questions there? Again, that takes us to our last segment for the day. And again, it's one more equation. So this day has been very equation heavy. And so you do need to go back and you do need to practice your equations, make sure everything makes sense to you. So this right here is the equation of a circle. Centered at the origin. 0, 0. So the equation of a circle centered at 0, 0 is an equation that always looks like this. It is going to be x squared plus y squared equals r squared, where r is the radius. Remember, the radius is half the diameter. And of course, your diameter is the longest line of a circle going from edge to center to edge, where r is the radius of that circle. All right, so let me show you that and turn this thing on. Let it go. Let me turn on the grid. Let me draw. Draw. All right, and so if I have a circle of length 3, radius 3, 1, 2, 3, 1, 2, 3. My circle of radius 3 will look like this. You know, I actually have a circle drawing tool, right? I don't have to draw it by hand. You know that, right? Doesn't look too pretty. But this circle is at the origin, and its radius, the length from the center to any edge, that radius is 3. And so the equation for this circle, it will be x squared plus y squared equals 3 squared, or x squared plus y squared equals 9. Questions there? So what that means for us is that if I was to give you this problem in reverse, let's say I have, for example, x squared plus y squared equals 25, you should be able to tell me what the radius and what the coordinates of the center for this circle is. First of all, just by looking at the structure, you have two numbers on one side, x squared and y squared, equals a number. Once you have that structure, you automatically know it's a circle. Now that you know it's a circle, you can then give me the properties of that circle. The center will be at 0, 0, the origin, and the radius will be the square root of 25, better known as 5. Note here that we're not saying the radius is plus or minus 5. The radius is a physical measurement, and thus it cannot be negative, right? And that's why we're just saying the radius is just 5. Questions there on my analysis of the equation? Another example, if I have x squared plus y squared is equals to 39, then the radius is going to be the square root of 39. That does not simplify, 13 times 3. And the center will be again at 0, 0. Questions there? Okay, it gets just a little bit more difficult. The equation of a circle that's not centered at the origin. It turns out the equation is almost exactly the same. Equation of a circle centered at point h, comma k. Now, don't ask me why they use h and k. I didn't make it up. Literally, my first math textbook I've ever saw, it was h and k. And every single math textbook I've ever opened is h and k. Maybe we should do something about that. Maybe because, this is the x coordinate and the y coordinate of the center. Maybe we can give it a different name, a better name, but h and k is what they use. What happens is your equation makes a small change when you move away from the center. The equation becomes x minus h squared plus y minus k squared equals r squared. It is virtually the same equation, except I have made an adjustment because the center has moved. That adjustment is subtracting h from the x value and subtracting k from the y value. Uh-oh, my R didn't draw, please. There we go. Oh, now it wants to draw. R squared. So, if I have x minus 5 squared plus y plus 10 squared is equals to 100, the first thing that we want you to do is to simply recognize that this is a circle. And because it's a circle, you know that somewhere in there is a radius and a center. Right? Your radius is going to be the square root of 100. So that's going to be 10. And your center is going to be the opposite of the numbers that you see. So you see how it has right here x minus 5? The center is going to be 5. And you see how it has y plus 10? The y coordinate is going to be minus 10. It's going to be the opposite of the value that you see. Questions there? Questions there? Okay, so if I was to draw a circle, and let's call this 3, let's call this 1, 2, let's call this 4, sorry. And let's call this 3 right here, and I put a dot right here. That's the center of my circle. And my circle looks like this. Beautiful circle. The radius right here, r is equals to 3. I can give you the equation of the circle. The center is at 4, 3. The radius is equals to 3. Therefore, the equation is going to be x minus 4 squared. Again, the negative 4 means I've moved over 4 units. Plus y minus 3 squared equals 3 squared, which is better known as 9. Questions there?
No.
All right, so that's all the time that we have. Hoping you guys have a nice weekend. Enjoy your Labor Day. Any other announcements that I have? No, I'm missing one last piece of this right here, and that's completing the square. We'll do that on Tuesday, but you can certainly watch the videos to get ahead in Canvas. All right. Make sure everyone has posted to the attendance posted to the discussion board. Once you've done that, you can have a nice day.
Thank you. See you later.
Thank you.
Oh, don't forget I have my office hours later on this afternoon as well. Later on this evening.
Thank you.